Evening class. This is going to be the solution for the stopwatch example that I gave earlier in the class. Right now I have a blank block diagram, and what I'm going to do is I'm going to talk you guys through each of the steps and explain a little bit of the thoughts that I had behind each step. First, let's go ahead on the front panel and drop down the gauge which we need. Because one thing that actually always bothered me, but for some reason I didn't make it this way. I'm actually going to count from 0 to 9, so that way I have the same number of flashes, but that's just for me. So let's change the scale. So in order to get to this, I right-clicked. So I went right-clicked, and I went to Properties, and then I went to Scale. I need to be better about saying that. So anyways, let me save this as my compulsive habit. So stop, watch, spring, let's say spring 2015. Okay, so so now what we're going to do is we're going to add for the requirements for this stopwatch, I need two buttons, a stop start button. So for the stop start button, I'm going to put down a boolean like so. And in order to find this boolean, remember right click, go to boolean. And the other thing I need to add is a stop button, but I'll add that later. I also need an LED. So I'm going to hide the name of the LED. So if I right click on the LED, go to visible items and get rid of the label. And there's one student that did this, which I thought was really cool. Actually, I thought it was pretty cool. Was basically he put the LED on the in the middle here, which was pretty cool. So when it would rotate, it would flash in the middle there. Okay, so we got our boolean, our button. I'm going to change the name of this from boolean to start/stop. So we know that this is basically going to be used to start and stop the second hand. So basically, we want this to click. Basically, when we hit start, we want this to start counting seconds. When we hit stop, we want it to hold that position, and then when we hit start again, it'll basically keep going. So, anyways, okay. So let's get to this. So the very first thing that we will do is we need probably a loop. So I'm going to put down a loop. And inside this loop, so I'm going to put down a while loop. And to get to the while loop, I right-clicked on the block diagram, went to Structures, and clicked on while loop. Now, in order to kill the program, what I'm going to do is I'm going to put create a control here, and I'm going to call this turn off watch, or let's just say off. Let's just call it off. So, and then we're going to drag this over to here. And then we're going to pull the name. Now the other thing is, actually I don't like this saying off there, so I'm going to stop here. I'm going to type, so basically I clicked it, double clicked here, and I can change the name. I'm going to right click on this and put visible items, I get rid of the label just to make it a little prettier. There's no reason that you really need to do that. But one of the things as you make programs in the future is you want to make it a little nicer. Actually, we'll call this, well, it was called stop, but we'll call this, yeah, that's fine. I'll just leave it off. Sorry, being a little, being my normal self. So, the inside the loop, what we're doing is basically, there's a couple different things that we can do. We need to we probably need to have the gauge inside the loop so it's updated every time the loop goes through. And then we also need to have the we probably need the start and stop inside the loop. So basically, once you start the program, this loop is always going to be constantly going. So we pretty much need everything inside the loop. One of the other requirements I have is for the light to blink on even and odd numbers. So let me take care of that logic really quick right now. So, oops, So I'm going to basically put everything inside the loop. I'm going to make this loop a little bit bigger. Now what I'm going to do is I'm going to add some logic in order to actually find even and odd numbers. So in order to find an even number, if you take a number, any integer, and you divide it by 2, you get you'll get a remainder of 0. So if we use the quotient and remainder, so basically, you know, if I feed in 4 and I divide it by 2, you'll get basically 2 and a remainder of 0. So I'm going to put down this little block right here. So this is the remainder, and this is, well, basically the well, if you took like 5 and divided by 2, then you'd get 2 remainder 1, and so this would give you out 2 at this point. So I'm not going to wire this directly into the light. Let me change the name of this light. Instead of boolean2, I'm going to say got odd number. Okay? So basically, we're looking for an odd number. Let me move that over a little bit. So it produces a 0 when we got an even number, so all we need to do is we can invert that. So we can just invert it, or we can use, so I can invert it under the Boolean, or I can go to comparison, and I can say not equal to 0. So let's say not equal to 0. Like I said, I could just, well, actually, sorry, we need a comparison. So I can't just use the not here because this is not a logic. So if I take this over and I feed it through here, it'll be like a type error. It might do what we're needing to when this produces. Basically, since we're dividing by 2, it should produce just a 1 or a 0, but we don't have a logic that's converting this. So it's better to do a comparison and than use a not. So let me get rid of that, and let me go ahead and save this. And so the remainder is x divided by y. So y is bottom. So right click, create constant. Let's put a 2 here because we want to look for remainders. Sorry, we want to look for, so looking for even numbers. So let me write a little note here. Looking for even numbers. So this guy will produce basically 0, and or you know, the other way you can think about it is logically actually looking for. You could also say looking for odd, because technically this is producing a 1 when it's odd and producing a 0 when it's even. So actually, let me say looking for odd numbers. So because basically when you got an odd number, you got a 1, which is a logic true, and when you got an even number, you got a 0, which is a logic false. So anyways, let's put this off to the side. We will use that later. That's basically the logic that we'll need for turning on and off the light. And I'll put that nice and neat over here. Okay. And then now the next thing that I want to do is I want the clock to basically update every second. So I can't just have this while loop running as fast as possible. Actually, we'll worry about that in a sec. Yeah, no, never mind. We'll take care about that now since I'm talking about it. So right click, go to timing, bring down a wait. I'll just put this right over here by the stop button. On the left side, I'll right click, create constant. Remember, this is in milliseconds, so I'll add a 1 second wait time. Wait 1 second. Okay. And now what we need to do is, well, we need to take care of the rest of the control stuff. So there's a couple different ways that you can take care of this. Is basically when you're starting, you can have it where it basically okay, so what's the best way of explaining this? So when you basically when you push the start button, you want it to start incrementing. When you press stop, you want to hold the last value. So what you need to do is put down what's called a case statement. Well, you can think of it as this is an if. So basically, if we're starting, so basically, if we put down this in the true case, basically starting to count. Okay. So we're starting to count, and what we'll do is I'll drag this little question mark box further up. So basically, when we press the button, this is a start case. Oops, let me wire this. Okay, and then in the false case, stop counting, hold number. Okay. So like I said, it's always good to kind of keep track of what you're doing in each one. So now the other thing that I need, to do is I need to keep track of what the max value is. Now there's an interesting thing is you can actually get the max values from the gauge and you can actually set it. But we won't do that because basically what you can do is under like advanced options or is it advanced? I forget. But there's a way to basically under create property nodes you can basically define what the max value will be somewhere under here. You can control it, but we won't worry about that. So also the gauge right here, I wanted to count in integers. So what we will do is we're going to do all our math in integers. So let me change the gauge type to an integer. So let me go to properties and data types, and let's go ahead and change this to, well, we're not counting very high, so let's go ahead and change this to unsigned 8. The reason I'm choosing unsigned is we're going from 0 to 9, and unsigned 8 is the smallest. We're not going to be counting anywhere beyond 255, so no need more than 8 bits. Also, one of the other requirements is that we need to zero the gauge in the beginning, but we'll do that here in a sec. Let me, okay. So when we are counting, we also need to have a shift register. So basically what we need to do is when we're counting, we need to take the last value, increment it, and then save it. Sorry, my phone just beeped. And then when we're not, we just need to pass through the last value. So let's take care of the false case first. The gauge is going to be showing what this value is. So let's see, what's the best way of wiring this up? So, okay, so let me first, and then, okay, actually this would be a good way of doing it. So first thing I'm going to do is make a local variable, create a local variable. And so what I'm going to do first, which might seem a little odd initially, I'm going to change this to read. So in the beginning, which I won't show just yet, is I'm going to initialize the gauge, and so that'll be initially at 0. What I'm going to do is, let me first create shift register, add shift register. I'm going to wire the gauge to the shift register, which changes the type to the type of the gauge, which is nice. And then what I'm going to do is I'm going to, let's take care of the so basically stop count hold number. So basically what we want to do is we just want to pass this through. So we'll connect it here and we'll tunnel basically all the way through. Okay? So now what we need to do is we need to take care of the true case. Let's see, hold on a sec. Look at the let's see. Okay, so now the true case, what we need to do is we also, inside the true case, what we can do here is the stopwatch is actually going to be counting, so we need to update the value. So right now what will happen is, well, right now it's not going to do anything, but if we don't press anything, 0 will just keep passing through. We also need to have when this guy is blinking, so what we can do is grab the value and pass it over to here, which is what we'll do. We can also grab it from beforehand, but it'll be always one iteration off. So you kind of want to grab it from over here. So if we go to numeric and go to DBL, so basically what I'm doing is I'm going to convert the gauge right here. So basically what I'm doing is I'm taking the current value and I'm going to blink if it's odd or not. Also I'm going to display that on the gauge. So it's basically going to, so basically what I'm doing is initially I'm passing in the gauge value, passing it into the loop, and then depending on the state of things, I'm either going to increment it or just continue to pass that value through. So now we need to go to the true case, and we need to add another case structure. Now the reason we need to add another case structure is we need to take into account rollover. So I'll add another little case structure, but before we do that, what we'll do is, let me move this down, I think that'll be good there. So what we're going to be doing here is we're going to be looking for if the number is less than 9. If it's less than 9, we're going to continue to increment it. If it's greater than 9, we're actually going to change it back to 0 because well, we want it to basically roll over. Now, in the original problem, it was 10. I'm just changing it up a little bit. So what we need to do is if we go right-click numeric, there is a add, but we can just do an increment plus 1. So what we'll do is we will basically add 1 to it. Then what we're going to do is the false case, well, let me add a little bit of logic here. So let's go to comparison, and what we'll say is greater than. So basically, let's think about this here for a sec. So if we are 9 and we just incremented it and we're technically 10, we want it to be 0. So what we want to do is we want to look for when x is greater than 9. So let's say right-click, create constant. I did this on the y, and let's change this to the max value of 9. In your case, that was 10. I'm just doing less counts. Remember that from the beginning. Now what we're going to do is we're going to wire this up to here. So basically we're, oops, hold on a sec. Let me first wire this so it'll set the type, and then I'll create a constant, and then I'll change this to 9. So basically it's doing comparison of the same type. Okay, so now what we're going to do is if it's false, this is the easy thing. If it's false, we're just going to pass the value through. False. Let's see. Here we go. Keep incrementing. Keep adding. Keep incrementing. So basically we're going to keep incrementing if we are less than 9. And here what we need to do is reset gauge to 0 on output. Okay, so we don't actually need, oops, I don't want to do that, I just wanted to move it over here. We actually don't need to really do anything in this one. What we need to do, well, we do, but we need to do is we need to create a constant, and that's okay, 0 here, but let me move it out of the way. Okay, and there we go. So now what we've done is basically when we are greater than 9, we're at 10, but we want to be at 0. So we change it to 0 and we pass that through. Otherwise, what happens is we just keep incrementing. So if the start button is true, what we're doing is we're going to be incrementing. If it's false, we just pass the current value. Basically, we just keep passing it, and the light will turn on or off depending on what the value is. Now, this program right here doesn't set any initial conditions or anything like that, so we need to take that into account before doing anything else. So what I'm going to do is I'm going to add a flat sequence around the whole thing right here. So basically I want to do this, and then initially I want to do initial conditions, but before that, so I'm going to add a frame before, and I'm going to say who this was created by. What's today's date anyways? 9th. Okay. 4/9/2015. It's always good to put who wrote it. Created by, and what you're doing it for, EEC10 demo video. And of course it's gone over and it's going to expand, but that's okay. Okay, so we need to do initial values. So basically I don't want the program to start counting right away, so I need an initial value for the stop start button. So let me go right click on that, create a local variable, and then another thing is I want this light, well, the light, it doesn't really matter, but I might as well give it an initial value as well, because we're starting at 0, which is technically odd, and it should turn off the light right away. But it's usually good to basically it's usually good to initialize everything you have to states that you know. So I'm going to create a constant, and I do want the light to be off, so false is okay, and I'm going to share this with the start stop button, because I want it to be false initially. Now the other thing that I need to initialize is this gauge here. Now I don't have to have gauge feed in this value. Actually, what I could do technically, well, this is probably a little bit better programming, get rid of the gauge, the local variable there. Let me do this, and let's delete this. And what I'm going to do is I'm actually going to, because I need to initialize my gauge in the beginning, change to right, and then what I'm going to do, oopsie, let's see, move it this way. No, you are not going to cooperate with me. Okay. And select the loop. Okay. Just wanted to make it a little nicer, that's all. Okay, so now what we're going to do is move this over a little bit. So now what I'm doing is I'm going to initialize the gauge, create constant 0, and then what I'll do is I'll just wire. So basically I'm setting gauge to be 0, and I'm also passing in 0 into the loop. So the way this should work when I start the program, and it's always good to kind of talk to yourself when you're writing a program, so you kind of, I didn't even use the iterative count, but basically what happens is, this loop right here, you can think of it as a do while. So basically it passes in, but this guy is going to be off. I mean, basically not going to kill it, so it's going to keep going. So it's going to pass 0 into here. This is initially false, and what it's going to do is, since this is initially false, it's not going to count. It's basically going to hold the number, it's going to pass it through, show 0, and it'll take the last value, or well, the initial value, pass it through and save it. Since this is 0, 0 divided by 2 is 0, so basically we don't have an odd number, so this will basically turn off. We'll wait 1 second, then it'll pass the value through in the next loop, and keep doing this until I press the start button. As soon as I press the start button, it'll take that 0, pass it here, increment it, and then what will happen is it's technically less than 9, so basically this is it's less than 9, so this is false because x is not greater than 9. So basically we're just going to pass it through, and we keep doing that until, if I don't press the start button, it'll keep doing that until this is 10. Then I'll change it to true, setting it to 0, passing that value through. And once I hit the stop button to stop the program, it'll basically just keep holding that number. So anyways, let me go ahead and save this. And out of good measure, if you want to do this as well, because this is usually a good habit to have, is if you go Edit, Make Current Values Default. So when you start the program, it'll start with these values as well. So let's go ahead and press play. So it's not counting, which is good. So let me see, I'll press the start button. I'm going to check first if it rolls over. It's blinking on the odd numbers, which is good. It does roll over, and there was no delay time, which is nice. Okay, so let's see. It does start stop right away, which is good. So I can sit here, click on that pretty quickly. And there you go. Now let me make sure it kills the program. And there you go. So now when I run it again, everything goes back to the initial conditions, which is good. And then we go start, stop. And it works out really quite nicely. So anyways, this is the solution to the stopwatch demo that you guys did for Lab 1.